Good evening, students. How are you all? Welcome to the session of quadratic equations. I'm Kanika ma'am, your mathematics teacher. So in the previous class, we were discussing about the quadratic equations, how to solve the same using factorization method. Now today we are going to learn how to solve a quadratic equation using quadratic formula. Now if we factorize ax square plus bx plus c, where a is non-zero, that means we are talking about standard form for a quadratic equation, into a product of two linear factors, then the roots of the quadratic equation ax square plus bx plus c equal to 0 can be found by equating each factor to 0. So that's all about the factorization method. Now the nature of the roots of the quadratic equation also we are going to learn today. Nature of the roots means that for a quadratic equation, we know that there are two roots. Now we need to check whether the roots are equal or they are unequal. Also, we have some cases where the quadratic equation has no real roots. That means there are no values of x which satisfies the equation. So that is called the nature of roots. Now this depends upon the value of d is equal to b square minus 4ac, which is known as discriminant of the quadratic equation. This means that if I have this as the standard form for a quadratic equation and I solve for the value b square minus 4ac, so b, a and c, I am referring to the values which we have here. A, that's the coefficient of x square, b, that's the coefficient of x, and c, that is the constant term. So b square minus 4ac. Here, this particular value is called the discriminant and is usually denoted by capital D. This is called the discriminant. Now, the nature of the roots means to check whether the roots exist or whether the roots exist, also if the roots are real and equal, to check if the roots are real and unequal, or if there are no real roots. That depends on the value of D, that is the discriminant, which we solve using b square minus 4ac. Now, if this value D, that's the discriminant, comes out to be strictly greater than 0, then we will say that there are two distinct real roots. There are two roots here, two real roots, and they're different. If D is equal to b square minus 4ac is equal to 0, we'll say that there are two equal roots. And if D is equal to b square minus 4ac is less than 0, it's a negative number, then no real roots. So there are no real values of x and y, which is going to satisfy this equation. Now, if we have real roots, if the real roots of the quadratic equation ax square plus bx plus c equal to 0, a not equal to 0, can be found by using the quadratic formula. Now, if the real roots exist, that means the discriminant is either greater than 0 or is equal to 0, then we can find the value of x. The roots we can find by using minus b plus or minus square root of b square minus 4ac upon 2a. Now this means this particular value which is inside the square root sign is actually the discriminant. So that is minus b plus or minus square root of d upon 2a. So if this discriminant is greater than 0 or equal to 0, then we can find the values of x. Minus or plus will give us two different values of x. Here it's written provided b square minus 4ac is greater than equal to 0. Because the square roots we can solve for either 0 or numbers greater than 0. We cannot solve for the square roots which are below 0, for negative numbers. Not possible in this case. Yes, we can solve. We'll actually learn this in grade 11. But for the time being, we are discussing about the real numbers. So we are going to solve for the square roots only for numbers which are equal to, which are greater than 0 and equal to 0, not below 0, not for negative numbers. So in this case, when discriminant is less than 0, we'll say no real roots, no real values of x and y, of x here, which is going to satisfy the equation. Now, I'll explain you this with the help of one of the questions here. Find the roots of the following quadratic equations if they exist using the quadratic formula. So we have this equation here, 3x square minus 5x plus 2 is equal to 0. Now let us compare this with the standard form ax square plus bx plus c is equal to 0. So here a is equal to 3, b is equal to minus 5 and c is equal to 2. So here we've got the values of a, b and c. Now we need to first of all check whether the roots of the quadratic equation exist. That means we are going to solve for the discriminant here. So here discriminant is equal to b square minus 4ac. That means we'll write here minus 5 square minus 4 into a into c. That is 25 minus, and then we'll multiply all of these. We'll get 24 here. So that will give us 1. So the discriminant here is 1, that is greater than 0. So we can say that there are real and distinct roots in this case. Now we know that the real roots here exist, and now we are going to solve it using quadratic formula. So the quadratic formula is x equal to minus b plus or minus square root of d upon 2a. That is minus b. Minus b would be here minus 5 plus or minus square root of d. D here is 1 upon 2a. 2 into a. A here is 3. So now we can write this as minus minus plus, plus or minus, that's 1. Square root of 1 is 1 itself, upon 6. Now it's plus or minus. So we'll first take the value from plus. We'll take the value from plus and then from minus. So we have 5 plus 1 upon 6, or we have 5 minus 1 upon 6. So this is either 6 upon 6 or 4 upon 6. That means we have 1 or 2 by 3. I've simplified this here and I've got 2 by 3 here. So the values of x we have 1 and 2 by 3. So these are roots of the given equation. Have you all understood, students? Now let us discuss one more question. Here again we have a quadratic equation, x square plus 4x plus 5 is equal to 0. And we need to first of all check whether the roots exist in this case. So we'll compare this with ax square plus bx plus c equal to 0. Here a is 1, b is 4 and c is 5. So the discriminant is given by b square minus 4ac. With the help of the discriminant, we will check whether the roots exist. So we have b, that is 4 square minus 4 into a into c here. So that is now 16 minus 20. So we are getting the discriminant as a negative number. It is below 0. It's a negative number. So in this case, there are no real roots. No real roots. So we cannot solve for x using quadratic formula or by any other method in any case. So no real roots. So we'll stop here. The roots doesn't exist. We cannot solve. Now let us solve this one. Now we have 2x square minus root 2 root 2x plus 1. So we are going to check whether whether the roots exist. So we'll compare this with ax square plus bx plus c is equal to 0. So a here is 2, b is minus 2 root 2 and c is 1. Now we'll solve for the discriminant, that is b square minus 4ac. That is minus 2 root 2 square minus 4 into a, that's 2 here, into c, that is 1. Now let us solve. This would be 4 into 2. Minus square will give us positive, 2 square will give us 4, root 2 square will give us 2. And this is also 4 into 2. So actually we'll get 8 minus 8. So the discriminant here is 0. Now, since the discriminant is 0, we'll say that yes, the real roots exist and there are real and equal roots. Real and equal roots. Now, let us solve this using the quadratic formula. We have the quadratic formula as x is equal to minus b plus or minus square root of d upon 2a. So, minus b means minus here. Minus minus 2 root 2 plus or minus square root of d. D we know it is 0 upon 2a. 2 into 2 here. 2a here is 2. Now please notice d is 0. So whether we are taking plus 0 or minus 0, that will not make any difference in the value. That is why there are real and equal roots, because the values will come out to be the same. Even if you add 0 or you subtract 0, it will not make any difference in the value. So now we are going to write the next step here. We have x equal to minus minus. This is actually plus 2 root 2 upon 4. You can also cancel out this. You will get x is equal to root 2 upon 2. Now please notice here, even if we have got one value, we are going to write it twice. So it is root 2 upon 2 again. Have you all understood, students? So here we've got the discriminant 0. We have put it here, and then we have used a minus minus 2 root 2 upon 2 into 2. And then minus minus will give you plus here, and 2 into 2 will give you 4. You can cancel out 2 and 4, and you will get root 2 upon 2. Since there are real and equal roots, we are going to write the roots twice. Even if we get one root, it's the same thing, but then still we are going to write it twice. I hope, students, you've all understood this. Now let's try this one. We'll compare this with ax square plus bx plus c is equal to 0. Here a is 4, b is 4 root 3, and c is 3. So we'll check whether the roots exist here. So this we have the discriminant b square minus 4ac, that is 4 root 3 square minus 4 into a into c, that is 4 square, that's 16 actually, into 3, and this will also give you 48. 4 into 4, 16, 16 into 3, 48. So that's actually 48 minus 48. So the discriminant here is 0. So yes, we have roots and they're equal. So we'll say real and equal roots in this case. Now since we have roots, we are going to solve this using the quadratic formula. Minus b plus or minus square root of d upon 2a. That is minus 4 root 3. We have the value of b as 4 root 3. Plus or minus square root of 0 upon 2a. 2a is 2 into 4. So x here is minus 4 root 3 upon 2 into 4 also you can write, and then cancel out 4 and 4. So you will get x as minus root 3 upon 2 minus root 3 upon 2. So here we have real and equal roots. Have you all understood, students? Yes. Now let us come to the exercises here. Now find the roots of the following equations. Here we have this equation. We are going to find the root of the same. So before we do anything else, we are going to bring it down to a quadratic equation. So we'll take the LCM here. We'll get x square minus 1 is equal to 3x. Now this 3x will go towards the left hand side. We'll get x square minus 3x minus 1 is equal to 0. Now we are looking for two numbers whose product is minus 1 and the sum is minus 3. So it's very difficult to find out such a number. So it's difficult to solve this using factorization method. So we are going to here use the quadratic formula. So for that, we need to first find the discriminant. So we'll solve the discriminant first. Ax square plus bx plus c is equal to 0. We are comparing this with ax square plus b plus c is equal to 0. So here a is 1, b is minus 3, and c is minus 1. Now we are going to solve here the discriminant. So we have d is equal to b square minus 4ac, that is minus 3 square minus 4 into a. A here is 1 and c is minus 1. So this is going to give us how much? 9, and 4 into 1 into minus 1 will give us plus 4. So here the discriminant is 13. The discriminant here is 13. Now we are going to solve this using the quadratic formula. So we have x equal to minus b plus or minus square root of d upon 2a. So x is minus b. Minus b here is minus 3. Minus 3 plus or minus square root of 13 upon 2a. 2a is 2 into 1. A is 1 actually. So minus minus will become plus 3 plus or minus square root of 13 upon 2. That's the value of x here. So here we have two different values of x. X is equal to plus 3 plus root 13 upon 2, and we have 3 minus root 13 upon 2. So here we have two different values of x. So these are roots of the given quadratic equation. Now let us solve one more. Here also, please notice we have x in the denominator. So we are going to first simplify this and we are going to bring it down to a quadratic equation here. So before we do anything else, we'll take the LCM here. So the LCM here is x minus 7. We'll take here in the numerator and x plus 4. And the LCM we'll take by multiplying these two. So we have x plus 4 times x minus 7. And I'm not touching the RHS here. I'll just write it down as it is. Now, let us take this minus inside the bracket. The signs will get reversed. We'll get x minus 7 minus x minus 4 upon x plus 4 into x minus 7. This also I'm writing as it is for the time being. Now let us solve. X and minus x will get cancelled. And then we'll have minus 11 upon, and then we can simplify this also. We'll get x square here minus 7x plus 4x minus 28. And then we have equal to 11 upon 30 here. We can cancel out this 11 and 11 and we'll be just left with minus 1 here. So we have here minus 1 upon x square minus 3x here. Please notice here from this step I have combined this. So it's minus 3x. Minus 3x minus 28 here. 28 we have written. I've just written this as it is. And then I have 1 upon 30. Now we can cross multiply this. Now when we cross multiply, we'll get minus 30 here. X square minus 3x minus 28. That I've multiplied with 1. So it's as it is. It is the same thing. Now let us take this on the right hand side. We'll get x square minus 3x minus 28 plus 30 is equal to 0. You can combine this and then you will get x square minus 3x plus 2 is equal to 0. Now this is a quadratic equation. Now we are going to solve this. We can either solve this by quadratic formula or we can solve it by split the middle term, by split the middle term method. That's actually the factorization method. Now it's very convenient to solve here because we want two numbers whose product is 2 and the sum is minus 3. So if I take minus 2 and minus 1, I'm going to get the product as positive 2 and I will get the sum as minus 3. So we can solve it by factorization also. This is very convenient. So we'll write this minus 3x as minus 2x minus x. X square minus 2x minus x, and then this plus 2 I'm writing as it is. There's no change here. Now we are going to take common here. So we can take common from here. We'll get x into x minus 2. And then we can take common here. We'll get minus. Minus I'm taking common so that I can get the bracket this. This bracket I can get again. It's important to repeat the bracket. If you don't do that, then you will get stuck and you will not be able to proceed further. So here x minus 2, we'll take out common and we'll be left with x minus 1 here. So finally we have x as 2 and 1. So these are roots of the given quadratic equation. Have you all understood, students? Now let us discuss a few word problems here. The sum of the reciprocal of Rahman's age in years 3 years ago and 5 years from now is 1 by 3. Find his present age. So this one is very simple. We are talking about Rahman's age. There is only one person here. So we are going to take only one variable here. So we are going to take his present age. Present age we are going to take as x years, and the age 3 years ago I'm going to take as x minus 3. And 5 years from now, that means 5 years later we are taking the age, that would be x plus 5. Now the sum of the reciprocal of the Rahman's age 3 years ago and 5 years from now is 1 by 3. So I am taking here the reciprocal of the ages here. and their sum is given to us as 1 by 3. Now we are going to bring it down to a quadratic equation in one variable. So we'll write here x plus 5 plus x minus 3 upon x minus 3 times x plus 5 equal to 1 by 3. Let us solve this. X and x will become 2x. Then we have 5 and minus 3 will give us plus 2. And then we can simplify this. We'll get x square minus 3x plus 5x minus 15. And right hand side I'm writing as it is. So here actually I've multiplied these two brackets. So I've got x square minus 3x plus 5x minus 15. Now from here we can take 2 common and we'll have x plus 1. And from here we can combine these two. We'll get x square plus 2x minus 15 is equal to 1 by 3. Now we can multiply this. Let's see what happens. So we'll get 6 times of x plus 1 here. And then we'll get x square plus 2x minus 15. So this can be simplified further. We'll write this as 6x plus 6 is equal to x square plus 2x minus 15. So we'll take both of these on the right hand side. So we'll get x square plus 2x minus 15 minus 6x minus 6 is equal to 0. So please notice here we have taken 6x and 6 on the right hand side, and the signs here they've got reversed. That's now minus 6x and minus 6. Now we'll combine the like terms. We can combine these two and we'll get here minus 4. So x square minus 4x. Also, we can combine this minus 15 and minus 6. We'll get minus 21. So now this equation we can either solve by factorization or by quadratic formula. So we want two numbers whose product is minus 21 and the sum is minus 4. If we take minus 7 and positive 3, that is going to give us the product minus 21 and that will give us the sum minus 4. So now here we will split the middle term and we will write this minus 4x as minus 7x plus 3x. Now we'll simplify this. Here we can take x common and we'll have x minus 7. And we can take here 3 common and we'll have x minus 7. Now further, we can take this x minus 7 common and we will then have x plus 3 that's equal to 0. From here, we can conclude that either x is 7 or x is minus 3. Now, we are going to reject this. We will reject x equal to minus 3 because we know that the ages can never be negative. The ages are always positive. That is why here x is 7. That means the Rahman's present age is 7 years. Rahman's present age is 7 years. So it's very important to write the concluding statement here. Do not just write x equal to this and leave the answer in case of word problems. Do write the concluding statement. Now let us solve the next one. Now in a class test, the sum of Shefali's marks in maths and English is 30. Had she got 2 marks more in maths and 3 marks less in English, the product of their marks would have been 210. Find her marks in the 2 subjects. So we have Shefali and she is given test for maths and English. In a class test, the sum of Shefali's marks in maths and English is 30. Let us say that she got X marks in maths. So now we know that the marks in maths and English, they add up to 30. So marks in English would be 30 minus x. So this is the original condition. Now case 2 here is, had she got 2 marks more in maths and 3 marks less in English, that means 30 minus x minus 3. You can also write this as 27 minus x. So this is case 2 where she gets 2 marks more in maths and 3 marks less in English. The product of their marks would have been 210. That means the product of these two, we have 210. So let us solve this. X plus 2 into 27 minus x is equal to 210. Now we can simplify this. This x will multiply here. We'll get x into 27 minus x. 2 will multiply here. We'll get 2 times of 27 minus x is equal to 210. Now this will give us 27x minus x square, and this will give us 54 minus 2x is equal to 210. Now let us take this on the left hand side, and we will get here minus x square, and also we can combine these two. This will give us 27x minus 2x will give us 25x here, and when we are going to take this 210 on the left hand side, that will become minus. So 54 minus 210 is equal to 0. So this is now minus x square plus 25x, and then we can solve this. This is going to give us minus 156. Minus 156 is equal to 0. Just for convenience, I am dividing this throughout by minus because I'm not comfortable dealing with the minus as the coefficient of x square. So I'm making this as x square minus 25x plus 156 is equal to 0. Now this is the quadratic equation which I have. I'll just write it again. X square minus 25x plus 156 is equal to 0. Now we want two numbers whose product is 156 and the sum we want minus 25. So if we take 12 and 13 here, we take minus 12 and minus 13 here, that is going to give us 156 as the product and will give us the sum as minus 25. So here we are going to write this as this minus 25x, we'll write it as minus 12x minus 13x. Rest of the terms remains the same, the first and the last one. Now we'll take here x common and we'll have x minus 12. Here we are going to take minus 13 common and we'll have x minus 12. Further, we can take this x minus 12 common. And then we'll have x minus 13 is equal to 0. So we have x either as 12 or 13. Now we already know that x we assumed as marks in maths. So that's either 12 or 13. So if we take this as 12, if we take this marks in maths as 12, because we've got x 12 or 13 here. So let's first take 12. If we get 12 marks in maths, we are going to take, we are going to get here in English 13 minus 12, that is 18. If we take here 13 marks in maths, in English we will get 30 minus 13, that is 17. So here there are two cases, 12 and 18 and 13 and 17. There is no reason here to reject any one of these. There's no reason. So we are going to consider both the cases. So if we have x is equal to 12, then 30 minus x will give us 18. That means that here marks in maths, in the first case, we are going to get 12, and marks in English, we will get 30 minus 12, that is 18. In case 2, when we are getting x is equal to 13, then 30 minus 13 will give us how much? 17. So in this case, we have marks in maths as 13 and marks in English as 17. I hope students, you've all understood this. Please notice here we are going to consider both the cases. Now let us discuss this one. The diagonal of a rectangular field is 60 meters more than the shorter side. Here we have a rectangular field. And let's say that this is the diagonal. The diagonal of a rectangular field is 60 meters more than the shorter side. Shorter side means we are talking about the width here. So 60 meters more, that means the diagonal here is x plus 60. If this is x, this would also be x. If the longer side is 30 meters more than the shorter side, the longer side is actually here the length. So it is 30 meters more than the shorter side. So it is x plus 30. That's the length here. We have to find the sides of the field. We have to find the sides. That means we have to find the length and the width. Now, please notice it is a rectangle. In a rectangle, all angles, they are right angles. So this is 90 degree here. Now, if this is 90 degree, let us name this as A, B, C, D. So we can say that this is a right angle triangle. Now, in a right angle triangle, we can apply Pythagoras theorem. So by Pythagoras theorem, we know that the hypotenuse square is equal to altitude square plus the base square. So now we can open the brackets here. We can solve here using a plus b whole square. So here we have x square plus 3600 plus 120x. So I have actually used the identity a plus b whole square, that is a square plus b square plus 2ab. And on the right hand side, this we are going to open the bracket using a plus b whole square here. That is, now x square I'm writing as it is. This one I'm writing as it is. There's no change. I will now apply the identity a plus b whole square. So this is a square plus b square plus 2ab. Now we can cancel out these two, and these two terms will go on the right hand side, so their signs will get reversed. So we have x square plus 900 plus 60x minus 120x minus 3600 is equal to 0. Now we have x square, and we can combine these two. We'll get minus 60x, and these two can be written as minus 2700 is equal to 0. Now we want two numbers whose product is minus 2700 and the sum is minus 60. So if we take minus 90 and positive 30, that is going to give us the product minus 2700 and will give us the sum minus 60. So we can write this one as x square minus 90x plus 30x minus 2700 is equal to 0. Now we can take common from here. If we take x common, we'll have x minus 90. And if we take 30 common here, we will have x minus 90 here. Now we can take this x minus 90 common. So we are going to get here x minus 90 times x plus 30 is equal to 0. So either x is 90 or x is minus 30. So we will reject this. We are going to reject this because we know that the lengths can never be negative. So we have x as 90. That means the width of the rectangle here is 90 meters. And we know for the length, it's already given to us that if the longer side is 30 meter more than the shorter side. So we've already solved for x, that is 90 meter. So the length is 30 meter more. That's actually 90 plus 30, that is 120 meter. So these are sides of the rectangular field. I hope students you've all understood this. In the next class, we are going to discuss a few more word problems. Thank you students. Take care.